For IsPrime, we'll use the same for loop that we've been using previously to check factors of a number. So using this hint here, we see that prime numbers have exactly 2 factors. So I'm going to allow the for loop to generate every potential factor from 1 to the number itself. Inside the loop, we're going to ask a question of those numbers I. And we're going to figure out if those numbers can evenly divide into the number itself. Okay, so that's what this does right here. Any number, say like 30, 6 is a factor of 30, so 30 modulus 6 would be 0. 7's not a factor of 30, so if we took 30 modulus 7, we wouldn't get 0. When I get this factor, what I want to do is I want to count it. So I'm going to make a separate integer, kind of like the sum integer I used in Lab 4, and this will be a counter. So all I'll do right here is say count plus plus. I don't need to keep a running sum, so I'm not going to add the value of I. I'm just going to increment count. Every number that turns out to be a factor of num will be counted. Well, according to that hint, prime numbers have only 2 factors. So I'm just going to ask a question now. I'm going to find out, did the count value reach 2? Notice that I've moved out of the loop. So I want to let the loop finish its process. I don't want to preemptively make a decision as to whether or not the number is prime. I want to wait and make that decision when I'm all done counting factors. Okay, so at this point in the program, I should be able to make the determination as to what type of number we're dealing with. And now it's just a simple if-else. There's no other scenario. It's either a prime number or it isn't a prime number. Okay, so if we go ahead and run IsPrime, I'll start off with a prime number like 13. Looks good. All right, let's run it again with what we call a composite number, 14, and it's not prime. I'll test another one just to be sure. 15, not prime. Only prime numbers should check out as prime.